The following is a presentation of the Six Arrows Radio Network.
This week on the Workbench, all about designing a remote monitoring system for a repeater site. Stay tuned. Welcome to the Workbench. I'm your host, George, KJ6VU.
And I'm Jeremy, KF7IJZ.
The Workbench is sponsored by Elecraft, makers of high-performance radios like the K3S, the portable KX3, and the ultra-portable KX2. Check them out at www.elecraft.com. And by Autodesk, the makers of Eagle PCB design software. PCB design made easy. Get your free copy of Eagle at www.autodesk.com.
Welcome to the Ham Radio 360 Workbench podcast, your bi-weekly source for deep technical dives on aspects of the ham radio hobby and other modern making topics. George, how are you doing tonight?
Hey, Jeremy, I am doing great tonight. And yourself?
Mediocre.
Oh, man, mediocre?
Again, it's been a week. Actually, it's been a couple of weeks.
Well, hopefully everything's okay. It's not like a disaster.
No, just a lot of death by 1,000 cuts. So, it's...
Are you living in interesting times while we're on that angle?
I don't get the reference.
Well, the Chinese saying, may you live in interesting times.
Okay.
Which basically means interesting times is sort of code for a miserable situation.
I understand. Thank you for enlightening me. Are you going to call me Grasshopper now?
I want to know, do you have an enlightening arrest?
Wah wah. Yes. Is that the MFJ one? Oh, anyway, yes, I was mediocre this evening. I am happy to be here doing the podcast with you, and my spirits can only go up from here.
Well, excellent. I had a really busy week. I had a busy work week, but I also got invited to present some stuff at a ham radio club. So that was a lot of fun. I went to the West Valley Amateur Radio Club here in Silicon Valley and got a chance to talk about portable HF radio operating, which was a load of fun. It's a great group, actually. A lot of fun. The best part was they had asked a question of the crowd. They said, okay, how many of you have ever operated backpack portable? And they went around the room, and there's probably 30, 40 people. And I'd say maybe 20% said yes. And everybody else was like, why would I do that? And then I got up there and I said, well, how many of you want to? And everybody raised their hand. So I thought, oh, thank goodness, because otherwise it'd be a really long night.
Well, that's awesome.
Yeah, it was great. We talked about radios and batteries. We used your battery content, by the way, and talked about antennas and how do you pack your stuff and all that.
Was this the same radio club that Kale's last guest came from?
Yes, actually, I met Kenneth live and in person. We met at dinner with a bunch of other guys first and then went to the meeting, so he was there.
I wasn't talking about Kenneth. I was talking about the most recent soda episode, Mr. Munger.
No, he wasn't there, but Kenneth is the APRS guy from two episodes ago.
KFW. Yeah. Well, that's awesome.
Hey, Kenneth. So, yeah, that was really fun. It was a good time.
Awesome, yeah. Austin Munger was the guest on last week's episode. Yeah, this week's episode. The previous episode. And he had actually mentioned that you would come in, I think if I remember correctly, that he mentioned that you had done a talk at his club. In the news this week, kind of a slow week, but I have a couple of interesting things. Yaesu has announced two new handhelds, nothing too fancy, just analog handhelds. The Fox Tango 25R is a 5-watt, 2-meter only handheld, and then the Fox Tango 65R is a dual-band, single-receive 5-watt handheld, which I believe is being positioned as a replacement or the successor to the very popular and indestructible FT60.
Does it look like it? I haven't seen those yet.
Not really. Like the display looks like a single line display in the middle of the case instead of being at the top. What does look nice is that the display itself is still that brilliant white with a very dark, high contrast liquid crystal display. So it looks like they're using their display technology. I don't know much more about it from there. I know One of the big draws of the FT60 was that it would run full power on AA batteries. Since this radio is so new, I haven't really seen accessories. I think the manual is available for download, but I didn't have a chance to look at it before the show. So I don't know if they're going to offer a AA case, and if so, make it full power. Because I know this radio does come with a lithium-ion battery, whereas the last one came with... it was basically 6 nickel metal hydride cells like permanently attached to a battery pack. So I don't know. We'll see. The FT60 was my very first amateur radio, and I will never get rid of it. And I have probably sold 100 of them since I've been a ham. You know what I mean?
Well, you can pound a nail with that thing. I think they're pretty well built.
Incredibly well built.
Yeah, that sounds nice. Was there something else they announced?
Well, yeah, that was the FT25R, which is a 2-meter version, 2-meter only version. And
okay.
I think street price for the 65R is going to be about $169, somewhere around there. So interesting to see. Of course, as we get closer to Dayton, we will start seeing more and more things start to leak out. I don't really have any other big things heading down that way. I do imagine that America will finally see the ICOM 7610 at Dayton this year, I would hope.
I would think so. By then it should be, since they gave a sneak preview of that at the ham radio fair in Japan.
Yep, so that's it on the new radio front. Another new product that came across my feed this week, which I'll pass on because, number one, it's very affordable. But for those of you playing around with software-defined receivers, things like the RTL SDR that we've recommended before, which is the $20-$25 SDR dongle, or if you're using something like an AirSpy or an SDR Play or any of these low-cost USB receivers. So the folks behind the RTL SDR, which is rtl-sdr.com, are now manufacturing an AM broadcast band high-pass filter for $15.
And why would you want that?
You basically to keep strong signals out of the receiver, especially on the inexpensive $20 RTL SDRs. If you're
okay. So it's a
high pass filter. Didn't I?
Oh, well, if I was paying attention, I would have noticed that.
In all fairness, in the notes, I do say broadcast band, then high pass filter. So you may have read it as band pass filter. Now, again, $15, you can buy them directly from them. I put a link in the show notes. Eventually, they said they'd be available on Amazon in about 3 months. But to point out, it is a high pass filter. So the filter basically starts rolling off at about, I think, 2.4 megahertz, which of course blocks out 160. But, I mean, maybe that matters.
Well, 2.4 shouldn't block out
160 meters.
Right,
yes, it's a high pass.
Yeah, right.
And that's the other thing, too. It is a high pass. It is not a band pass. So if you're using this thing, it would also prevent you from doing any VLF type stuff or LF. So probably not a big deal for the majority of users. I also understand they released an FM broadcast bandpass filter, also for $15, in case you are around a lot of really strong FM transmission sites, which just helps, reduce the overload of energy going into these little tiny receivers, which do not have robust front ends.
Yeah, that's a pretty good idea. If you're in an area near a big broadcast site, I'm sure that thing would get overloaded. So also in RTL SDR news, for those of you who haven't been there, rtlsdr.com, not only do these guys manufacture these very affordable receivers, but they do an incredible job of keeping up a blog of stories of, tracking what other folks who make dongles do. So like they cover a lot of AirSpy news, for instance, which is really nice. They cover people's projects. So like I noticed there were some really good articles on getting set up to do ADS-B airplane tracking. But another article that caught my eye was that somebody has actually made a pre-built Raspberry Pi image that you can download that is specifically designed around plugging in an RTL SDR USB dongle and setting it up as an APRS receive-only iGate. So you can use that as a ground station to pipe APRS data into the internet?
That's exactly what you use it for. You set it up so that it will pick up APRS traffic in your area and pipe it onto the internet. It's,
Okay, so you could be like a satellite receiver for for vehicles driving around if there's no high sight to
that would be one
it.
Option if you pair the Pi with your phone, say as a hotspot, or if you live in an area like Kale where there just isn't a lot of APRS traffic, like he could put in a fill-in. I almost said a fill-in digipeater. It's not a digipeater because there's no transmission, but you could put in a fill-in iGate, which would just pick up anything it hears and forward it on to the big internet pipe.
I would love to do that. I have so many projects backed up. I'll probably never get to it, but I would love to do.
Yeah, that would be awesome. So that's it for my newsy stuff this week. George, do you have any newsy stuff?
Oh, just a couple little things about 2 weeks ago now we did Baycon. That was a load of fun. We had great presentations, a big turnout, biggest turnout ever, about 160 people plus registered. Thanks for dialing in on Skype, Jeremy, to do your presentation. People loved it. It's really hard to do a presentation over Skype to a big crowd and not have people kind of drift off. But people were seriously glued to the presentation, and the delivery was great. And I think everybody really enjoyed it. You had quite a few questions.
I did. Thank you for the kindness. Now, here's what's sad. So I had intended on recording my side of the presentation so people would see the slides, and I went and checked the video, and it didn't work. So I have the audio, but what had happened is where I was broadcasting PowerPoint from a different monitor, the software that I use to record Skype will only record the screen that the Skype application is on. So I basically have the recording of the Skype application. So I see Skype, the window, and my little box in the bottom of it, but I don't actually see the presentation except there at the end when I go out of full screen mode. So that was disappointing. But like I said, I have the audio in. I don't know how valuable it is because I was reading a lot of facts and figures off of tables and charts, which are all of that information is actually available in another video on my YouTube channel, which I'll put a link into. But I think the questions at the end that I got were pretty good, and we could probably include in a future episode because there were definitely some good, smart questions asked at the end.
Well, we have all of those questions and your audio recorded. So for the Baycon episode of the Workbench, I was planning to include that. So we published several of the presentations on our website already. If you go to our club website, www.bay-net.org, that's bay-net.org, up at the top of the page is a link that says articles. If you click on articles, it'll take you to a page with a bunch of presentation material that we've delivered at various conferences over the years. And the top 6 links there are 6 of the presentations that were delivered at Baycon. So we've got your analysis of SLA and LiFePO4 batteries. We have that presentation posted. We've got Ed Fong, WB6IQN, who's a famous antenna guy from the University of California at Santa Cruz.
He was also a recent guest on Ham Radio 360.
Exactly. Yep. Cale interviewed him, and he did a great presentation on J-pole antenna design, and that presentation's up there. We had Ed Lafarge, W6ELA, who wrote a software package called Whiskers, and it's a embedded automation system software suite, I guess you'd say. And he used it for a couple of projects. The most recent project is doing remote radio control. So he's got it set up to remote Elecraft and Yaesu and Kenwood radios. It's pretty slick, and he's made it open so people could download and use it. We had Brian Yee, W6BY, who is a big-time microwave guy and really an expert RF designer. Brian did a presentation on operating above a gigahertz in general, like what could you do above a gig. So most hams, maybe you have a UHF radio, but that's as high a frequency as you go. But there's a lot of high frequency, bands that we can operate. And then we had our favorite antenna analyzer designer, Barrick, K6BEZ, who did a further extension of the thoughts on the antenna analyzer and talked about building more RF test equipment on the cheap. We also gave away a bunch of his, a bunch of our Ham Radio 360 PCBs for the antenna analyzer as door prizes. And then Jason, K6DGN, did a presentation on a topic that I thought was pretty cool. He had the idea that he wanted an external battery for his handy talkie, in this case an ID51, and it takes like 12 volts to charge it from a wall wart. And his thought was, well, I can take one of these big 5-volt batteries that are used to recharge cell phones or tablets and use that to charge my radio. But of course, I have to take the 5 volts and boost it up to 12 volts. So we went out and found a boost regulator, put it together. Now he has this really cool battery booster to charge his HT. So anyway, he goes through the whole design on the presentation. So it's pretty fun. So all those presentations, the PDFs of the presentations are on the web. And in the next episode of the Workbench, we'll have some of those presentations live. So for the rest of you who couldn't make it to BayCon this year, you'll be able to pretend like you're there by listening to some of the presenters present their stuff.
Awesome.
So anyway, that was a big deal, a huge effort on the part of the club members to put it all together. We had a great time, so that was good. We even had a long-distance guest join us in the flesh, and that was John Pugliano. So you guys might remember John from an interview Cale did with him several episodes ago about operating mobile HF. And John is also a podcaster. He has a show called the Wealth Steadying Podcast. And John's out in Utah, but he had some reasons to be out here on the West Coast, and he managed to schedule everything so we can come by BayCon.
Awesome.
So that was awesome to see John. Yeah. So
Hi,
we
John.
went out to dinner, had a great time. Hey, John. Let's see. The other thing, I finally got my kit from QRP Labs. It showed up a couple days ago. So this is my Ultimate 3 QRSS Whisper transmitter kit that was designed by Hans Summers. So a really interesting guy with a great website. So haven't built it, of course, yet, and probably won't get to it for a month, but I hope to. I hope to get it done by field day.
Cool. You should send an email to him and bring him on the show.
I would love to. Actually, I have been emailing with him because I had some questions about what you could do with this hardware besides what he's done already, and we've chatted a few times about some things, and we will definitely get him on the show. I think he'd be a great interview. So that's about it for now.
Well, that's all awesome. Have you had time to do anything on your Workbench? No is an acceptable answer.
Sadly, I have.
Well, I'm not. I don't have too much going on. So one of the things that was really draining about this week is we had somebody in my neighborhood had their house burglarized. And it was a good reminder to do things like make sure my insurance coverage was up to snuff, and then just start looking for things that I could do around the house to improve sensing. Of course, with all this microcontroller talk, it would have been very easy in theory to start building door sensors or window sensors or motion sensors and all this. And I thought about that. This is one of those areas where, okay, the time to build it and report and record on it, that in and of itself is a project, but not having all the pieces at hand virtually guarantee it's not going to get done. So I don't have. What's sad is Micro Center, their home, I don't know, their house brand. They have a house brand called Inland. They sell like Arduino Uno clones for $5 and like Mega 2560 clones for like $7, and micros that have the serial header pins instead of the USB connector they sell for like $5. So technically I have no excuse not to have a drawer full of Arduino stuff. So I ended up settling on a couple of commercial things, and the good news is that at the end of the day we finally learned that the homeowner had basically accidentally left a garage door open and hadn't locked the door between the garage and the house. So it was the folks were in there for probably less than 5 minutes, and it was definitely a thing of opportunity because they left quite a few things in the house. So it was clear there was kind of like a smash and grab, only without the smashing. So that helped. But a good reminder to make sure that you have proper coverage on your homeowner's policy for things, and if you so desire to add the coverage that we've talked before, that you can get coverage through the league, but there's also talk to your insurance company about an inland marine policy, which would cover your equipment both at home and if you're taking it portable. So the other thing that's kind of been going on is sadly, literally the weekend before it was supposed to ship, I canceled the order for my Prusa i3 Mark II 3D printer.
Because you're going to get some better?
So this is the following is purely my opinion, and I just want to say that because I still think that the product overall is fantastic. The features at the price level is fantastic, but they have a forum, and there had been some people complaining about fans, like cooling fans that are required to keep the hot end from destroying itself or getting clogged with filament. or having one of the, there's like this PT or TPF, PTFE, TPFE.
TFE,
Yes,
Teflon.
yeah. There's this Teflon tube that takes the filament and runs it through what's known as the cold zone before it gets to the hot zone. And if these cooling fans were failing, then the hot zone heat creep starts happening. The cool zone starts getting hot. That starts melting. The filament melts in there and gets clogged. And so bad juju. And I'd seen quite a few people on the forums talking that this had happened to them, and it was concerning only because, these printers. I ordered mine on 11/28. And so, a little over 2 months before it was going to ship. And I canceled on a Sunday, and they're like, your printer's going out tomorrow. Are you sure? And I was like, yes. And I'm just concerned that, like a lot of small companies, and they had probably 10,000 orders or more in a very short period of time. And they deserve all of the credit for the quality of print and some of the very novel things they put in the firmware. But I've just decided that it's entirely possible, and this is me being overly cautious. And again, this is just purely my opinion. I'm not saying what anybody else should do with their stuff, but I'm just concerned that in an effort to meet the high demand, there may have been some shortcuts on the supply chain side. Maybe some of the fans they got were lower quality. And since I'm very risk adverse as a person, which you should be able to tell because I just talked about how on my Workbench was insurance. But so I just decided that I still want the Prusa i3 Mark II. I still want to order one, but I'm just going to wait until the demand has died down a little bit, when they have a chance to kind of catch their breath and they have a little bit more time for assembly. And actually, honestly, I'm also considering going from a fully assembled kit to fully assembled printer to a kit, because there are a few little upgrades that some of the community, and this is the beautiful thing about it, it's an open source printer. So there are a few little improvements that the community has come up with that would just be easier to install probably as you're building the printer, rather than taking apart the assembled printer and then getting it back together. So, and the kit ends up being a couple $100 cheaper, and then you don't have to pay a $70 import duty on it because it's under like some $800 threshold. So again, I still intend on picking one up. I've just decided I'm going to wait and just make sure that there aren't like big patterns of things going wrong.
So how will that be different than the printer you've got now?
Well, several different ways. The biggest things are in my opinion, the hot end that it comes with. It's a top of the line, like really premium hot end brand. It's an E3D V6, a genuine E3D V6. Larger temperature range, which means you have more filament options, a lot of nozzle options, which give you more filament options to be able to print things like carbon fiber filament or metal doped filaments and whatnot. So that's a big draw. For me, the build area is much bigger because it's about 8 by 9 by 10, whereas currently,
wow,
yes,
that's pretty big.
And that's for under $1,000. Whereas now I have 8 by 4 by 5. The some of the features that they built into the firmware, even if you build the printer and the printer is out of square, the bed detection system will actually correct your prints in software to make sure that even if your axes aren't perfectly square to one another, that it will still print a square print. Which is pretty awesome. There's a future upgrade going to be available that you can print with multiple filaments at the same time without having multiple print heads. It would allow you to do up to 4. I mean, it really has a lot of amazing technology. The heated bed is a very good design because it is designed to evenly heat the entire bed, whereas oftentimes you'll see a bed that has a heater in the middle of it, therefore the edges get cool much faster than the center. But they've designed around that. Like, there's just a lot of novel thoughts into this thing, and so it is still the printer on, and then the quality, as somebody had said, it punches way above its weight. It prints almost as good as a $3,500 Ultimaker, and for a printer that's under $1,000, like really technically under $900 assembled. I mean, that's incredible. So there's still one in my future, just not right now. But the reason I bring this up is the other thing I've had on my Workbench is it just so happens that PrinterBot has been releasing all kinds of upgrades for the printer I already have, including an actual metric Z-axis screw, which matters because when you're doing the math on layer heights, if you're using a standard Acme screw, which I have now, all of your millimeter layer heights go into extreme floating point. Whereas if I have a millimeter lead screw, then all the math works out very nice and neat as, tens of millimeters. So that'll improve print quality. It should also hopefully help address an issue that I've had with my Z-axis, with the Z-axis being periodically off. What else? New extruder, getting a gearhead extruder, which actually synchronizes both sides of the gears that pull the filament into the hot end. And this is good because it's also auto tensioning. So that will just actually make it capable of working with other filaments a little bit better. Also, a little bit better grip and control of filaments running through it. New fans, new cooling fans, a new LED light kit so you can actually see the print bed while it's printing a little better. So just a few things here and there. One of the things that they used to sell an LCD controller that's actually it's pretty much the same thing that's on the Prusa i3. So you get a 4-line LCD with a rotary encoder with a push button built into it. And the firmware on the printer is such that you plug a display into the printer and it will give you all kinds of statistics and allow you to do control from the printer itself without having to use a computer. The reason that this is interesting, or I'm bringing this up, is that PrinterBot used to sell this for like $100. Well, it's based on an open source design for RepRap printers that you can buy on Amazon or eBay for like $15 all day long. The only difference is the wiring is different. So as I was looking around for solutions to create a new wiring harness from my printer to the board I ordered, I discovered this cool little kit on Amazon. So these header pins are 0.1 inch pitch, pretty standard, what we're all used to working with very commonly, right? So this kit comes with a myriad of what are called DuPont connectors. Are you familiar with DuPont connectors?
No,
so I
don't know what that
didn't
is.
know either, but if I showed you one, you'll be like, oh yeah, of course I know those. They're basically the connectors that are one row, 0.1 pitch connectors where you have the little metal clip that crimps onto your wiring harness, and then you slide it in there and it goes click. If you built computers ever, it was the thing you would have seen for like your audio cable coming off your CD-ROM. It comes with a female, comes with even header, rows of header pins like we had with the antenna analyzer that we had folks order for like $16, and it's like a 650 part kit. You add like an $8 15-foot 10-wire wiring loom, so you can strip pieces off, and then I found out there's a crimp tool for these things. It's available for like $23. The sad thing is I was looking for dies since I already own a ratchet and crimp tool, but the dies would actually be more expensive than to buy the crimp tool on Amazon.
That sounds
so
useful.
I'll make sure I have links on the show. I was about to say, I can't believe I've talked this long getting into this cable thing, but then I remember the episode where we talked about 3 hours for screwdrivers. So I'll make sure that I have this information in the show notes. And then the last thing that I will say, kind of related to something that's topical, is folks will notice that it has been a while since we've had antenna analyzer boards available for sale in the store. One of the large reasons is not that we can't make more boards, but our supply of diodes has gotten a little dry. In fact, I think we may have a bead on some coming from Greece. We've had listeners reach out to us and say things like, hey, what about these? And the long and short of it is none of us have taken the time to try it. I've got a link, or like from suggestions that have been made from personal acquaintances. Some folks have suggested things online. And then also just looking at what NTE has created as the quote unquote drop-in replacement for those germanium glass diodes. That's something I'm going to try to get my hands on and try to start experimenting with, just to see what happens.
I don't think that'll work, by the way. I looked at the NTE data sheet is incredibly thin on data, and I got a sneaking suspicion it's not going to work from what little data is there.
So that was for the direct replacement. Then I have a friend that builds HF transceiver, like analog transceivers from scratch, and he recommended some very, 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 very low forward voltage dropping diodes that are designed specifically for sensitive mixing applications. Or detector applications, rather. I don't remember what the number was off the top of my head, but it's worth a shot.
Yeah, and that's what you need because it's an RF sensing circuit. You need a detector diode. It's not just a rectifier. And by the way, I did talk to Barrick about doing a revision to the design so that we can get away from using these difficult to find diodes, and he's going to start looking at putting a little amplifier circuit in there with a regular, high speed Schottky or some other sort of diode to see if he can make that work just as well. So I think that's going to happen, but it's going to be in some amateur unit of time.
Yes.
So that may be a bit.
Might be by the time he retires. But yeah, I mean, and if that happens, it ends up being a version 2 of the product, and the BOM cost goes up and the complexity goes up. The board size has to increase. So, I also hear tale that these diodes are available on eBay, but I think we are intending on having these for sale at Dayton, whether we have diodes or not, and then we may just leave it up to our users to experiment or to source them themselves. I actually recently, you remember when we had the parts discussion? And I had mentioned to you that Micro Center sells these Elenco kits that it's like 100 assorted diodes. Well, apparently the diode kit for $20 at Micro Center actually includes 3 of these germanium diodes that we have.
Oh, yeah. No kidding.
So,
so people are going to run out and buy this
$20 on
pile of diodes, throw them all
except
away,
except for two. Well, and the third one, because in case they break, right? That's so, but anyway, I mean, more info on that as it becomes available. Unfortunately, I haven't had much time for stuff lately. And yeah, I also want to say there is some incredibly exciting work going on. The antenna analyzer by the community. Like, we have somebody who used a relatively, I won't call it high resolution, but an OLED, like a 2.5 inch OLED display that actually draws the SWR curves across the band. And it's just cool. Like, thank you guys so much for being out there doing that stuff, because it is awesome.
Yeah, I saw that. I thought that looked really great. I was very impressed with that.
If I were a good host, I would remind myself right now to put a link to that in the show notes as well. Yeah, you'd think I'm just brand new to podcasting.
Hey, I do have one more thing. I want to drag you back to the 3D printer for a sec. So I got an email from Seed Studio. And if you guys don't know Seed Studio, they're a company in China that started some years ago, and they sell tons of handy do-it-yourself components and breakout boards and microcontrollers and stuff like that. Very similar to Adafruit, but in China. Anyway, so their stuff's pretty good, and they also do some services. And one of the services they've kicked off is a 3D printing service. Now, it probably wouldn't be noteworthy, except in the email, it describes all of the material they can 3D print. And I find it hard to believe they could actually do some of these things. And I'd love for you to take a look at this at some point. So they claim that they print nylon powder PA2200, which probably means something to you. They also print photoresistive resin SLA. So, okay. But then they list the following materials: high strength steel, iron nickel alloy, cobalt chrome, and EOS aluminum.
Yeah, those aren't things that you're going to have in a home printer anytime soon.
I find it hard to believe you can 3D print this stuff anywhere. Is this true?
Yeah.
It must be.
There was a printer at CES by a company called Markforged, which I think they are actually going to be selling. I could be making this up, but it's like a $5,000 desktop metal fusing printer. But there are absolutely laser. I think it's laser sintering, maybe, where there's like a powdered metal deposited and it gets melted together as it prints.
This is the kind of thing that, like you said, you probably would never have a 3D printer to print this kind of stuff. But if you know it's out there, you could print a plastic prototype of something and then do it in one of these metals. This is
so actually amazing. It's a lot of work. But even if you don't have a metal printing printer, if you are familiar at all with lost medium casting, where you basically you take an object that you want to make a casting of. Wax is pretty common. Styrofoam is another common one. You pack it in sand, and you put in a couple of channels to pour your material in. Then you take like a molten aluminum or copper or steel or iron, and you pour it in, and it completely disintegrates your model, and it fills the void that was left by your model, and then you pour it, you let it cool, and you remove the mold material, and then you have a rough casting of the thing that it destroyed. A lot of cool videos on YouTube of people doing lost PLA casting with aluminum and copper and iron, so check that out.
Oh, I never even thought of that.
I mean, again, it's a lot of work. Although, I mean, you can surprisingly set up a smelter, or I don't know what to call it, but basically like a crucible thing where you have an oven that hooks up to just like a normal 20-pound propane cylinder. There's a crucible that goes inside of it that you put your raw aluminum cans in, or your pennies, or whatever metal that you want to smelt in the temperature range that it's set up for. And it comes, you can buy the tools to safely handle it. And then you go just build the molds yourself. And you can do it in your backyard. Again, it's really dangerous, and do it at your own risk, because there's an extreme chance of burning the living crap out of yourself. Don't even try it. Forget I mentioned this. We take no responsibility. No smelting.
Home smelting made easy. And home do-it-yourself dental work.
You can cast your own fillings. That we joke about that, but I mean, two really good examples of 3D printing in medicine is for those of you who have the Invisalign mouth guards. When they take a casting of your teeth for those are, if I understand correctly, they are using a 3D printing like technology to make them, which there's a patent on apparently. But also the crown in my mouth was 3D printed.
Oh, no kidding.
I mean, they took a mold. The mold was, they took a reverse mold. The mold was scanned, and then a machine using whatever you put in crowns, some type of ceramic. I have no idea actually. But yeah, the first crown that they made for me was made by some dude who makes crowns by hand. And it wouldn't fit on the post correctly, so they had to end up going with a 3D modeled and printed version.
Well, very good. So anything else?
Isn't that enough? I think it's...
I think that's more than enough.
Well, actually, before we jump into tonight's show content, which is finally the payoff and all the microcontroller stuff we've talked about, that, we've gotten some good responses on the call to action we've had the last episode or two about if you have projects that you are either starting in the middle of or have finished, we want to hear about them. We want to hear what's on your workbench. We want you guys to send an email to workbench@hamradio360.com. Give us a little bit about your project. And I don't care if it's you decided to sit down today and turn all of your cables into power pole cables, if it's as simple as that. Or if it's as complex as I've decided to build a transceiver from scratch. I mean, all levels of projects we want to hear about.
I want to hear about the guy that's making his own transistors.
Out of 3D printed parts that he's there's some.
Yes. Well, if you can 3D print some silicon and dope it properly, then yeah, why not?
Did you know that PrinterBot actually sells tooling heads for their printers to print candy? So you can print in chocolate, or you can print in gummy bear material.
That's really
so. Anyway,
funny.
we want to hear about your projects, and we want to schedule an interview with you for inclusion in an episode dedicated to our listeners that we'll be putting together for sometime in March. So send an email to workbench@hamradio360.com with some of your details. We'll get back to you, and we'll see if we can schedule an interview and bring you on to share it with our audience.
And we'll be right back after this. Elecraft is a premier provider of high-performance transceivers like the K3S and the portable KX3, and their new super portable compact KX2, which is my top pick as a portable HF rig today. It runs 10 watts, 80 through 10 meters, single sideband CW and data modes. It's a fantastic little radio, and you'll be amazed when you see what kind of performance you can get out of something this small. And a high-capacity internal battery lets you run the radio for several hours, whether you're on the trail, camping, or taking the radio anywhere portable. You'll really enjoy using this little rig. With an excellent reputation for product quality, innovative designs, and customer service, check out Elecraft at www.elecraft.com.
So, George, a confluence of things brings us to our topic tonight, starting with the fact that Not only do you have a distinguished career as an electrical engineer and a very high passion for the amateur radio hobby, your interest in repeaters led you to starting a company that sells very high-end, very highly capable repeater controllers. Your involvement with the BayNet repeater network, and then most recently our deep dives on microcontrollers. How do you interface microcontrollers with things? Last episode, how do you communicate with microcontrollers wirelessly? And all of that goes into the soup that is tonight's discussion, which is the BayNet repeater system remote monitoring and control project.
For a little bit of background, so I've been building repeater systems for a long time, and I guess if you do anything long enough, you become pretty good at it. But I'm always learning something. I mean, I don't really profess to be a total expert at this stuff, but you certainly do learn a lot along the way. And one of the big project we started, like you're saying, was building a repeater controller that goes back over 10 years ago. And one of the clubs that I'm very involved with is a big linked repeater network called the Cactus Intertie that's got a huge number of RF linked repeaters throughout the Southwest. And the control systems were always built for the Intertie specifically. And we had run out of controllers and they were no longer being made. So a friend of mine, John, and I decided that we could do that. How hard could that be? And like a lot of projects, you greatly underestimate the work involved in it. But we jumped in with both feet and we designed this repeater control system. That was pretty cool. And we learned a ton. I mean, the best thing about that project was learning about how to use microcontrollers and becoming very familiar with the hardware that's out there and how to write the software for it and all that. So it was just a great way to kind of get our feet wet and learn about how to do it.
Now, I do have just a quick question about the Cactus Intertie. What's the furthest distance that two people could make connection via RF?
Let's see. Well, we go from Northern California, where we are. So let's say 2/3 the way up the state. So Sacramento, the Bay Area, all the way down to the Mexican border. And then we go from the Pacific Ocean all the way to the Gulf Coast. So there's repeaters from the Gulf Coast all the way to the Pacific. And then there's coverage in California, Arizona, Nevada, New Mexico, Texas continuously. And then there's pods of coverage in other areas that we use voice over IP links to get there. But that's about less than 5% of the network is over VoIP. It's all RF. So to go from Northern California to, let's say, Austin, Texas, you go through like 20 repeaters. You hop from repeater to repeater. And the way we do that is we don't use the repeater inputs and outputs to link. Those are just where the user goes in and out. We have separate full duplex RF links, and they've historically been like typical UHF kind of bands of operation, but there's a lot of parts of the network that use microwave, typically 2 gig ham radio microwave stuff. Commercial radios moved into the ham bands.
Well, that's cool. That's a whole other show, but I just to give people an idea of the size and scale of the repeater network, I kind of wanted to get that out there. So most recently, you had shared with us that you and several of the club members in the Bay Net had spent a great weekend up on the quote-unquote mountain at the repeater sites installing a bunch of equipment. So why don't you talk to us a little bit about how did this project come about?
So this particular project, the site monitoring system project, came about because we got sick and tired of driving to the repeater site to find that we had a blown fuse or a bad piece of coax. I mean, typically as a repeater owner, if you have a site that's far away, if something goes bad, sometimes you can guess what the problem is and sometimes you don't. And you just drive up there and check it out. And half the time, even if you bring a bunch of tools and parts and subsystems like replacement radios, you get up there and you find that you don't have the thing that you need. And if your repeater site is a couple of hours away, you could shoot a whole day just getting there and dinking around once you get there and then driving home. So we thought, well, why don't we figure out a way to instrument the repeater site and monitor kind of the vital signs, if you will, of the repeater site. So Let me give you a scenario. So you wake up in the morning and you go to chat with your buddies on the commute to work, and you press the PTT button and let go, and there's nothing there. Repeater's off the air. Why is the repeater off the air? It could be off the air because it lost power at the site. It could be off the air because the transmitter power amplifier failed. It could be off the air because you popped a fuse in the power supply. There could be a number of reasons why you don't hear anything. And we wanted to figure out if we could insert sensors in the radio system from the power to the antenna at key points and measure what's going on. We could look at that information and then diagnose the problem. So if you go to key up the repeater and don't hear anything, and you can look at a status page of the data, you might say, oh, look, AC power's on, good. The 12-volt power supply is putting out 13.8 volts, good. The power going into the radio is 13.8 volts, good. The push-to-talk signal is going to ground, so the logic is working, good. But there's no RF coming out of the transmitter. Okay, well, now I know the problem. The problem is in my transmitter. Now, it could be something else caused that problem, by the way. It could be that there's a bad antenna or something that caused the PA to blow up. But you know the problem is a bad transmitter. So rather than going up there with a new power supply or thinking, well, maybe the power's just off, you can hop in the car and take a replacement transmitter up there and be pretty much assured you've figured out the problem before you get there.
Well, that all makes sense.
Yeah, so it's all really in self-defense. I mean, it's really just how do we minimize the amount of time that we have to take to go fix it? Because a lot of times you go there, you go, man, I don't have the thing. I don't have a spare transmitter. Then you go back home, and if you're lucky, you have a spare. And then you got to drive back up there the next day. And so now you're shooting 2 days. And so there goes your weekend.
So obviously there's you mentioned a lot of different things to be able to monitor for, and obviously you have equipment for monitoring for those various things, but then also you have to have some kind of way to get that information off the mountain, if you will. Is it on a mountain? Yeah,
well, yes, it's at 2,800 feet.
That's a mountain.
Is a coastal mountain. I mean, for California, that's not a big mountain, but it's 2,800 feet, so it's got some altitude.
Okay, so walk us through, I guess, your guys' approach to the solution. Like, let's talk about, did you guys, use off-the-shelf equipment that was available? Did you design your own boards and have, manufacture them and write your own code? Like, so, I mean, just overall, your approach to this problem, was it do it yourself, or was it a bunch of commercial off-the-shelf stuff?
It was all do it ourselves. And part of the reason is that there was nothing off the shelf that did exactly what we were looking for. And we could find things that were kind of like what we wanted off the shelf, but really weren't as well integrated or didn't work in the ways we wanted it to work. So just like the repeater control system, we said, well, heck, we could do that. Whether we could or not, we didn't know, but we thought, well, we'll give it a try. That's the whole point of this hobby. So we just decided to design it and see what we could make work. And like most things, you can get something to work without too much trouble, but to make something really slick takes a lot of effort, of course. So we're still working on it. It's not totally done. I mean, it works, but we have more ideas of how we can make it even slicker.
So, I mean, we've on the show, we've covered a lot of probably at a high level, all the topics that one would need to have a rough understanding of these things. I mean, walk us through how did you quantify the problem? Like, how did you start designing what the solution set would be?
Well, it really goes back to what I was describing a minute ago, which is figuring out what are the most critical things you want to monitor in the system. So it kind of breaks down at logical interfaces between pieces of equipment. So AC power going into a power supply, DC power coming out of a power supply, float voltage of a battery, RF power coming out of the transmitter, forward and reflected power on the feed line to the antenna, temperature of the PA, or maybe even some logic states like, is the transmitter transmitting, is the receiver receiving, receiver signal strength. All of those are kind of the critical vital metrics that you'd want to monitor. If you were there in person, what would you do? Well, if you're there in person, the first thing you do is say, well, is the power on in the building? Yeah, power's on in the building. Is the power supply putting out 13.8 volts? And you'd pull out your voltmeter and you'd stick the probe on the power supply to make sure you got 13 volts. So essentially, we just thought about it as, what would we do if we were physically there with some test equipment? And could we make something that takes those same measurements and provides that data to us over the air or over the internet or some way, so we can actually see that information? And not only does that give you this ability to monitor stuff, but if you can do that, you can also control things as well. So you can also push commands to the site monitoring system and actually actuate relays and turn things on and off remotely, which, as it turns out, the more sophisticated a repeater system you have, the more you're going to want to be able to do that. And we could talk about, well, let's give you one example. If you're running any kind of voice over IP computer or D-Star or a Fusion or anything where you have a computer in the mix, and that's being a gateway into the internet, at some point, something's going to hang. And an example is the Fusion repeater we put up there. We were one of the very first beta sites for the DR1 repeater. And on a couple of occasions, the thing hung in transmit. And it was some goofy mode where somebody had their mobile radio set with some GPS receiver coordinates being transmitted, or I forget what the thing was, but it should have worked perfectly fine. But the controller in the beta repeater controller kind of went nuts and decided to transmit, and there's nothing we could do about it. So the thing was in transmit. We had to drive up to the repeater site, power cycle the repeater, and it was all fine. Well, if we had a relay in the power lead going to the repeater, we could have remotely controlled it. Now, normally you do that with a repeater controller, and you do it with a DTMF command. So you can say, well, I could solve that problem because I can just send it a sequence of DTMF digits and open or close the relay to power cycle it. And sure, we've done that for years. But having a more comprehensive system with a lot more sensors and a lot more relays gave us a lot more power.
All right, so let's walk then through the process of this. I mean, I'm assuming that for every one of the topics that you mentioned, like monitoring, power supply voltage, battery voltage, RF, the relay boards, temperature sensors, the measuring, like you said, forward and reflected power. I'm assuming that for each one of those, you designed using Eagle a discrete module.
We did design multiple boards, of course, using Eagle as the board layout tool. And we also bought some sensors off the shelf and plugged them into the board. So some things we made, some things we plugged in. If I take a step back on the architecture, one of the things that we looked at was, how do you get the data back to the user? So, like I said, a lot of repeater controllers, including our own repeater controller that we built, there are some digital inputs and digital outputs that you can use to flip a relay or two. But once you get past a dozen or whatever, you're kind of done. And we wanted a lot more variety of sensors, like digital temperature probes and stuff like that. So what made more sense was to create a new controller that only did this sensor reading and relay actuation. The next question was, how do you interact with that thing? So we wanted to design the system so that the sensor controller boards were loosely coupled to whatever the user's interface was. And because there's two different ways we want to get to the controller board. We want to be able to connect that controller board to the internet. We're very fortunate that particular repeater site has internet access, and so we can just jack into the internet. So that means that we can either SSH through a text shell into a computer and then talk to the controller, or we can serve a web page or something like that. We'll get to what we did in a bit. But if you don't have internet access, we wanted to be able to access the same site controller stuff through the repeater controller, which means that we need a way to send DTMF control codes to the repeater controller and have that then send a command to the control system to say, what's the voltage on the battery, and then have that send that data back to the controller, and then have that data come back to us in the form of audio in some way. And so we wound up architecting this thing so that the system is essentially in two parts. There's a controller that has a variety of sensors and relays on it, and we made actually 3 different versions with different kinds of sensors. And then we have two different ways to talk to it. You can either have a little Linux computer that's a gateway that goes between a TCP/IP Ethernet connection to a wireless data radio that talks to those controllers, or you can put that wireless data radio and that Linux board in the repeater controller and have that connected into the DTMF tone decoders in the repeater controller. So it's a lot of words to say that there's two ways to get to it, internet or repeater, and then you have that controller. And there's a variety of different controllers that we made for different purposes, and you can have multiple controllers at the site to distribute it around the facility.
So one question that comes to mind is, because I kind of, to your point, wanted to start backwards, and that's what's the outward facing and then going back into the repeater site. But so you're talking about these controllers, having two modes of operation, one being, getting stuff to the internet through a computer, or being connected to the DTMF stuff in the site. Is there like one central controller for the entire site, and that there are a lot of sub-modules that communicate to it? Because you mentioned that the controller has sensors on it itself.
Yeah, there's two different things. There is a single board computer that is the gateway, and the single board computer that we used is a BeagleBone Black. And the reason we used that was it's a pretty industrial controller, has a bunch of serial ports. It's got an Ethernet jack on it, and its form factor makes it very convenient to plug it upside down onto a motherboard. So
I actually have a comment about another reason why that is actually a better choice than a Raspberry Pi.
It's got an eMMC.
Yeah, it's got eMMC storage. I can tell you that anything, especially data intensive, where you're going to be writing to the SD card a lot, you don't have a known lifespan before the SD card craps itself.
Yeah.
That's the worst thing, is if you lose the computer because the SD card has gone down. Now, granted, there's beta support for net booting and booting over USB, but I don't know that I would trust it necessarily in a productionalized environment.
Well, in our case, like a repeater site has the unique problem that many times you can't get to the site for a lot of the year. So here in Silicon Valley, I could get to our repeater site 360 days out of the year. There's probably 3 days that it rains too hard, but these repeater control systems are installed on mountaintops that you can't get to in the winter. They're literally snowed in, and you can't get there except by helicopter or a snowcat. So we have to build everything so it's really robust, and that's sort of part of the requirement. And using an SD card is a big failure point for something that you have to be guaranteed is going to run unattended for many, many months in a harsh environment. So the Bone is a way better choice. And and actually, when we picked the Bone a couple of years ago, it was also a faster processor than the Pi. Now, the Pis have done a great job of catching up. So in terms of functionality, they're pretty close to the Bone, so to speak. But you still have that eMMC downside problem. So by the way, for those of you who wonder what we're talking about, what this is it's a memory chip that behaves like a disk drive. It's essentially an electronic hard drive that's non-volatile. So rather than installing the booting operating system on an SD card like a Pi, you install it on this little chip that's soldered to the board. So you don't have any problems with wearing out the SD card if you write to it a bunch. By the way, it's also very possible to either have the connections on the SD card get noisy or to have the SD card get ejected by mistake, all of which are going to be a disaster for your otherwise robust installation. So sadly, there's a lot of reasons not Pi. Now, there's some Pis that are more like little plug-in DIMM modules, and those would be a better choice. But anyway, that's kind of an aside. So back to your question, Jeremy.
Well, one other thing to point out about the BeagleBone Black also is that, and this was something that I actually didn't appreciate until we had this conversation. The BeagleBone Black, in addition to having a single core, I think 1 gigahertz CPU, half a gig of RAM, so raw computing power not as powerful as a Pi 3, but there are, if I'm not mistaken, there are 2 discrete microcontrollers on the board, each with a ridiculous number of GPIO. Like you said, plenty of serial, I2C, SPI, like all kinds of opportunity to interface to things in the real world, way more than you get on a Raspberry Pi.
Yeah, so that's right. So the 2 microcontrollers that are built in, we never even used those. Frankly, we didn't really have an application for it. But those are really real-time control microcontrollers that interface to the main CPU, which is running Linux. Now, all of the ton of I/O could be available to the microcontrollers or to the main CPU. So, at a top level, if you compared the Raspberry Pi, the original one, to the Bone was way better in virtually every dimension. The Pi 3s, like you're saying, really caught up in core performance, and they've added more I/O. But when you look at the Bone, it's got 4 available UARTs on it, and the Pi 3, I think, is still just 1.
It's technically 2, but one of them is a degraded experience because of the way they implemented Bluetooth. And so, yeah, you have you have one real UART and one that's a mostly UART.
So even if we say it's still 4-2, so it's twice as many, the Bone actually has ADCs, analog to digital converters, built in. We don't use them, but there are ADCs built in. The Pi doesn't have any built in. But, that's not a big deal. You can add an ADC with an external chip. The other thing is that early on, the Bone was built on a TI Satara ARM processor. So TI licenses the ARM architecture, and then they make various product lines. And one of the product lines is called Satara, which is their industrial grade controller chips. So these chips are really designed to be in a harsh industrial environment. And the original Pi Broadcom chip was not quite as beefy a chip. But like you said, they've really kind of caught up on the processing side, so that's kind of a moot point. So anyway, that's and the Bone physically has 2 rows of female 10th-inch center headers running down the sides of the board, so that when we fixture that board, we make a motherboard, and you take the BeagleBone and you plug it in onto a set of male header connectors upside down, and it works great. Don't need any mechanical fasteners because you've got so many header pins to hold this thing in place. It's not going to fall off.
That's hilarious.
So it worked out
I would
fine.
still have mechanical fasteners, but that's still good to know.
Yeah, it's really not necessary. But anyway, so that worked out great. So the heart of the system is this BeagleBone running Linux. And originally we ran Ubuntu. In fact, we're still running Ubuntu, but we will probably move to Debian, which has become the official release for the Bone. So that's the heart. Now, you can think about that. That thing's job is to do only one thing. All it does is it provides a TCP/IP connection on the Ethernet jack going to the internet, or rather, one of the UARTs is connected to a little XB data radio. And from the previous episode, we talked about Zigbee chips or similar chips running the 802.15.4 Zigbee lower half of the Zigbee stack, which is used often for building automation. So it's basically a low data rate, i.e. a couple hundred kilobits a second, mesh network data radio that you talk to it just through a UART. So there's no fancy programming. You just fixture this little part on the motherboard, and through one of the UARTs, you can talk from the BeagleBone's Linux environment to that transceiver. On the other end, on a controller board, you have a mating receiver transmitter, another Zigbee radio, and that talks through a UART into a PIC microcontroller. And then that microcontroller has a bunch of I/O, and the I/O could be an ADC input or a temperature sensor or flipping a relay or a digital input or whatever we design that board to do. So from the data radio on the controller in its power supply and its controller chip, that is identical on any of the controller boards. The only thing that's different is the complement of connectors and any signal conditioning stuff that we might have in front of that I/O.
Okay.
So in the simplest system, what you would have is, in an internet-connected system, you would have 2 boards. You'd have a gateway board, and you'd have a controller board. The gateway board talks TCP/IP into some router that you can plug into, and then on the other end of the internet is a server that originally was running on AWS. Now it's running on Google in the cloud, and you point your web browser or your mobile device to that website, and you can see the status of that controller. So if it's measuring a DC voltage, you'll see a gauge that shows you the DC voltage and a little display with the numbers that represent that voltage.
Cool.
So the simple user interface is on the web, something you would expect. Here's a bunch of dials and gauges and buttons and stuff like that. The other user interface is going through the repeater controller, and we had to do some stuff differently there. So the repeater controller, the way we designed the thing, it's in a 3U rack, and there's a main CPU board, and then for every radio you plug into the repeater controller, it has its own separate line card, and you can go from 1 to 8 ports. So you can actually run 8 repeaters or 3 repeaters and 2 links or 2 repeaters and 3 remote base stations or whatever mix and match of radios and computers that you want. You just plug in more boards up to 8. And the BeagleBone plugs into that rack on a host adapter board that plugs into the 3U rack. So we had to make a host adapter that plugs in, that provides power and also a serial port from the repeater controller across the backplane to the host adapter, then over to the BeagleBone that's mounted to it. And then you plug your Ethernet. You can also plug Ethernet into that if you want to actually go on the internet. If you just go through the repeater controller, then there's no Ethernet. So at that point, what the Bone's job is to interface through a UART on one side going to the repeater controller and a UART on the other side to the controller over the data radio, just like we did in the first example. So we had to write a bunch of code that runs on the Bone that takes commands from the repeater controller, decodes them, and then does something if it recognizes a legit command.
And those commands are serial?
Those commands are all serial. So the way that works is normally on the repeater controller, if you do something like enter *123 that turns link 1 on, for instance, you'll just get some telemetry tones, beep, to tell you that that function took place. You can interrogate it and tell me what's the state of it, and it'll come back in CW and tell you link 1 is on. But what the Bone lets you do is it lets you create voice telemetry. So we built a voice telemetry software package to go with it. So if you punch in on DTMF through the repeater and put *123, for instance, the repeater controller decodes that and says, oh, you punched in 123, I'm going to send an ASCII set of characters out the UART across the backplane to the Bone. And you can tell it whatever string you want. And let's say the string you send is Jeremy. The Bone is sitting there waiting for that serial data to come in off the backplane onto a UART. So it's sitting there constantly watching the UART. And when it sees Jeremy come in through the serial port, it says, oh, Jeremy, I recognize it. That's a command. And then it runs a script in the Linux software. And you can put whatever you want in the script. So in that script, you can have a command that says, send this command over the data radio to the controller and interrogate the controller's temperature, for example. The controller then responds with a string back to the Bone that says the temperature is 75 degrees. Our Python code takes that data and then it will key up the transmitter on the repeater and it'll convert that data message into a spoken phrase. So it'll say, for example, PA temperature is 75 degrees and then shut off the transmitter. So we had to write a bunch of Python code in the middle that runs on the Bone that does that. We had to create a voice library, and that all works fine. So you can cobble together your own voice library or messages or whatnot, and it's all open source, so you can do whatever you want with it. So,
well,
yes. I know I just threw about 20 things at you at once. I know.
Well, so I just a quick question. So, I mean, I get the keying, and obviously a lot of this stuff has been custom built to work with. I'm assuming that the repeater controllers at the site are Sierra Radio Systems repeater controllers.
Yes. So,
and if you've spent any time looking at your equipment, I mean, you have a very nice architecture with these, a backplane and all these different options. So, I get keying the radio is pretty simple. Again, you're probably doing that over serial to the controller to say, turn the radio on. How are you getting audio out of the Bone?
That's a great question, because the bone doesn't have an audio codec built into it.
Yeah, well, it'll do audio over HDMI.
It's passing HDMI data, but you can't get analog audio.
Correct. Yeah, there's no way to get
natively.
analog audio.
So we made a codec board. So like you do. So there's a reference design from TI for an audio codec that is supported with drivers on the Linux distro for the bone. So we took the reference design and re-implemented it and made a little circuit board so the codec talks to the bone over I2S, not I2C, but I2S. I2S is like a high-speed serial data channel that's used for streaming voice data typically. So that's on the digital side talking to the bone. And then the other side of the codec board is analog audio in and out. So that analog audio comes off the codec board onto the host adapter that also holds the bone. And then we route that audio to a pin on the backplane that then goes over to the master CPU board, where there's an audio mixer input port reserved for this auxiliary audio source. So from the time we designed the repeater controller a long time ago, we always had the idea that someday there would be a voice telemetry board that would plug into the repeater controller. And we just never got around to it because all the voice synthesis chips were awful. And we kind of just punted until we realized one day, we could do this with a BeagleBone. So we created a big voice library and wrote this Python code, and now we can shove the audio into the mixer, and that will go to whichever transmitters it's supposed to get routed to. And
I'm assuming then you guys recorded all of the, temperature and then 5.
Yeah, so the way we did that is we just wanted to use WAV files. So we wanted to make this really open. So the way the software is written, we wrote a program called Speak, and it's written in Python. And to invoke it, you just say Python Speak and then a series of words with spaces in between them. That's a command line in Linux.
Oh, so you didn't record?
No, we did. So the way you trigger it is you would say Python Speak net tonight at 8 p.m., for instance. That presumes that you have a set of MP3 files or WAV files, one called net.wav, one called tonight.wav. So you get the idea. So for every word in the sentence,
gotcha,
there is a word that's been recorded into a WAV or MP3 file, and we assemble that message on the fly. And we made like 900 words, I think. And of course, nobody wanted to volunteer to speak 900 words because they didn't want to do it. So we went
I would have done that.
Actually,
I want to be a guest on the Bayonet Repeater.
We would love you to do that. So what we wound up doing, we'll come back to that thought in a sec. So what we did was we got some voice synthesis software, and one of the best packages is stuff that was originally developed by AT&T. I think originally at Bell Labs. Anyway, they've licensed it to a bunch of different companies that all make this audio synthesis software most commonly called Natural Reader. So you can buy this stuff, or there's like a free version, and put it on your PC, and you type plain text and hit the go button, and it speaks the text back at you. And I think the free voice is kind of crummy, but you can spend a few bucks and buy the better quality voice synthesis modules, which we did. And so what we did was we typed up a gigantic text file with all the words and phrases that we wanted. And then we just shoved it into Natural Reader. It generated a gigantic WAV file. And then we just chopped it up into a bunch of little pieces. And voila, 900 little WAV files. Now, the other thing that's cool about that is that's if you want to build a complex sentence on the fly. If you want something else, like let's say you want somebody in the club to say something special like net tonight at 8 o'clock as a single phrase, you could record any arbitrary phrase like that as one single WAV file or MP3 file and just have it play that one file with that whole thing. So maybe you've got an event coming up and you want to promote the event on the repeater, and you can create a single web or a single audio file and just play it.
Well, and out of curiosity, since there is a web front end for all of this, I'm assuming that you could also, in theory, SSH in and just have it speak.
Yes.
From the command line.
You could do that too. You could do that.
So this controller board, again, it's a full-blown Linux computer, ARM-based Linux computer, the Beagle Board Black. You've been saying Beagle Bone. See, the problem is originally there were things called Beagle boards. This is the Beagle Bone Black. There are also Beagle boards. Okay, Beagle Bone Black. You've talked about, you've got in the wireless, the Zigbee stuff to be able to talk to the other sensors, right?
Mm-hmm.
We've talked about the interface you guys built specifically to the controller there. You mentioned there's a temperature sensor on board. So again, assuming this thing is in a rack.
Yes. So it was designed to fit in a 1U shallow rack chassis.
What other direct, sensing does this board do besides its own temperature?
So there's a couple different boards.
And that, so just to be clear, that's ignoring the stuff that it's getting from the Zigbee links. But like you had talked about, there were some sensors on the actual controller board.
Yeah. So the controller board is mostly, well, let me just go, I can run through the list. You can measure a DC voltage. You can sense a logic input through an opto-isolator, like a switch closure. You can actuate a relay. There's small relays built in, and one big one as an option. You can plug in a digital temperature probe cable, at the end of which is a small metal cylinder with a digital temperature probe. And we made a special board that has interfaces to directional couplers to measure power, RF power. So we wanted to look at the forward and reflected power on all the feed lines. So that's the basic set, and then how you hook it up to what you hook it up to depends on the application.
Well, I'll tell you what. Why don't we take a break? We've done a good overview. We've been focusing mainly on the controller, and when we come back, let's talk a little bit more about some of those onboard sensors and specifically using the information we've talked about in a couple of previous episodes. How did we implement them? And then let's get into the remote boards, the Zigbee remote boards.
The Workbench is sponsored by our friends at CADsoft. They're the makers of the Eagle PCB design software, the very software George used to design the Pactena Classic, Pactena Mini, what him and Barrick are using to create this new antenna analyzer project for you here on the Workbench. They got hundreds of parts libraries, tons of reference designs, and a monster huge user community. Eagle's a great choice for your next ham radio project, and you can get your free copy of their software today. Click on over to cadsoft.io and start getting your project put together today.
So George, the sensors on the controller. It sounds like even standalone, this thing has a lot of capability, both from a power monitoring. Like I was really surprised to hear that you have the RF monitoring built on the main controller board. I guess in my mind, considering that the controller was going to be nothing more than the controller and then the repeater controller interface, and that everything would be off board, if you will, so you had maximum flexibility. But this sounds really cool. And obviously,
but it actually, but what you described there is the way it is. So there's there's two parts. There's a gateway piece, and then there's the controller piece. The gateway part doesn't have any sensors on it. It's strictly a communications device. So
that's like the mother brain.
Yeah. So the host that holds the Beagle, its sole job is to communicate between the sensor network and either the internet or the repeater controller.
I gotcha. Okay.
And all of the physical interfaces are all in the controllers separately, and they're talked to over the Zigbee network.
Okay, then I misunderstood that. I apologize.
Well, that's a reasonable way to. You could certainly build it that way. We just split them into two pieces,
which at the end of the day makes it more flexible.
Exactly, and scalable. So you might have a small installation that needs just a few things, or a big installation where you have a bunch of stuff you want to instrument, but that could all go through one gateway.
Right, and no matter what, having a single BeagleBone Black is just basically table stakes to start monitoring at the site.
Correct.
So let's get into the different types of sensors. The ones nearest and dearest to my heart, and the ones that I'm most likely to understand, of course, are going to be your power supply voltage sensors and your battery voltage sensors. Tell us about those.
Yeah, so the main thing we wanted to do is just look at the voltage. That tells you most of the story. And voltage measurement is really simple, and we talked about analog to digital converters on earlier episodes. And the simplest thing you want to do is just take a DC voltage input and scale it to the range that the ADC on the microcontroller can handle. So the parts that we're using are 5-volt parts. So I could put a maximum of 5 volts DC into the ADC input on the microcontroller. And of course, if I'm going to measure 13.8 volts and maybe up to 20 volts, I need to reduce that down. And so I need a voltage divider, just simply 2 resistors, and I can scale that down to a voltage range that won't blow up my microcontroller. And then in the software, I have to convert that voltage measurement to the actual voltage. So if I do a 4-to-1 divider, if I measure, let's make this really easy. If I measure 16 volts, physically 16 volts, out of that 4-to-1 voltage divider, I'm going to get not 16 volts, I'm going to get 4 volts. So in my software on the microcontroller, I have to read that and say, 4 volts equals 16. So what comes out of the software says 16 volts. So I have to convert in the software that 4-volt measurement back to 16. But the math is trivial. It's just a multiplication, so it's very easy.
So if this is the I forget what you called it, not the gateway board, but the controller board,
right?
Are those how are those temperature sensors attached?
Okay, so temperature sensors is a whole separate thing.
I'm sorry. I misread the notes. I lost my mind for a second. But those voltage sensors are they just wires run out or
right? So the way we did the wiring was. We used a pluggable compression terminal block. So terminal block is you've seen a million of these things. It's a plastic housing. The wire goes into a hole, and you turn the screw that's captive. And as you turn the screw, there's a compression plate that squeezes down on the wire.
Yeah.
And there's good ones and bad ones, by the way, which I didn't realize until we really got into this. So all the ones on the consumer Arduino boards that are cheap out there, the blue ones, those all compress downward onto the wire, and there's a little metal piece in there that as you screw down, it kind of goes at an angle, which doesn't make for a very good contact. The better ones are called rising clamp terminal blocks. What happens is when you screw the screw, it actually ratchets a horizontal plate upwards to crimp the wire. And it's not at an angle; it's parallel to the wire itself, so it has a much better contact.
Yes,
and they're of course they're a little bit more expensive, but they're well worth it. So, and of course those come in different kinds. There's the kind that you solder to the circuit board, and then you stick in the wire and screw it down. The ones we use are 2-part. There's a male piece that you solder to the circuit board that has pins pointing outward to the back of the 1U chassis, and then there's a connector that has the female side and the rising clamp and the screw part. And so that way you can plug and unplug the wires by unplugging that terminal block. And you can get those in 2 to 10 different screw terminals per block. So you can get them in different sizes. We use a 3-position one.
Cool.
So by the way, one thing that I learned along the way is what I just described seemed kind of like an obvious way to do all this. Once I got into it, I talked to some people who were professionals at designing this kind of equipment, not this application, but more robust kind of sensor gear. And one thing that they mentioned that I never even thought of is they said, well, in your application, measuring 0 to, let's say, 20 volts referenced to a common 12-volt DC ground makes sense. But not all systems will want you to do that. You might want to measure, let's say, that voltage, but not with respect to your chassis ground, but with respect to a remote chassis ground. So it has to be fully differential, meaning that it's not referenced to the ground in your system. And there's applications where you might want plus and minus voltage. So the very simple case I described is really easy for anybody to do. If you want to do...
Hold on.
Yeah.
You just said differential, and then 10 seconds later said the really easy case.
So the really easy case is non-differential. Really, meaning there's a common like in our system. The way we build stuff is everything is chassis common ground, and so the 12-volt battery's negative lead is the same as the frame of the rack.
Yep.
It's the same as the negative on the radio. It's the same as the negative on the repeater controller. It's all one big ground. Now, that's fine for our application. But if you have this sensor and you want to measure maybe the voltage not in this rack but in the other rack, and you want to use the negative potential connection in that other rack, not yours. And if you connect your ground through this controller to the other rack's ground, you might be causing a ground loop.
Yeah, and this is where you mentioned in the last episode where you had the Zigbee sensors.
Right.
And they were like, well, it's a good thing you designed it to avoid that problem. And you're like,
yes.
Yeah, of course we did.
So that's another dimension to this is how do you connect to a bunch of things at a site without binding all the grounds together and creating problems.
So, I mean, it sounds like for voltage then, if you have, if that power supply is racked in the same rack as the controller, like you said, the battery negative is tied to the ground or tied to chassis ground of that rack, using the wire direct sampling method is totally adequate.
Yes, perfectly fine, super simple.
And you don't even like the run of the wire. Did you guys do anything special? Like, did you use heavy gauge wire? Because obviously you're not really getting much of a current over the line.
Yeah. So in this case, since the controller's in a 1U rack, we don't want to run a big heavy cable up to that box and through it and down to the load. And all we're doing is measuring the voltage. We're not measuring the current. So we just run some 2-color zip cord 18 gauge wire, and it's perfectly fine.
Yeah, that's probably actually a really good size for that. So that's the direct sampling method, but then you also have Zigbee voltage sensors, correct? Or maybe you're not doing it in a separate rack for that.
Well, there's one other thing that we want to do for DC power, which is to monitor current as well, and that's we haven't done this thing yet, but it's just work. We haven't just gotten around to it. And the idea would be a small board that's got a little processor in the radio, and you would mount it at the battery bank itself and run the load wire off the battery through the sensor so you can measure not only the voltage, but you can measure the current. And I don't want to haul that wire somewhere to a sensor. I want to haul the sensor to the wire so that there's no extra resistive drop on the cable.
Right.
But we haven't gotten around to that yet. That'll be a pretty simple project.
Okay, so that would be the wireless.
Yeah. So, but we also are still running wireless between the gateway and all the controllers, whether they're in the same rack or across the room. So, in one of our installations, we've got a rack that has the gateway and it has a controller because there's a battery bank in it.
So this is another fine point that I missed, because in my mind there was a centralized controller, then all these tiny little Zigbee boards, whereas no, the controller is universal design that has an entire sensor suite on it, and there's one per rack basically.
Yeah, one or more per rack. So
or more.
So like in our case, we have let's say rack number 1 is a network rack, and in the network rack we put the gateway. Then in rack number 2, it's a radio rack, and it's got repeaters and the repeater controller and power supplies. And in that rack, we put a 1U chassis with a variety of sensors and relay controls. So we can measure the DC voltages, we can measure temperature, we can measure a bunch of stuff. We also made a second controller, another 1U, and all it does is monitor the RF power because it's a different board. And so we have multiple directional couplers that plug into the second module to measure the power forward and reflected to the antenna.
Well, so I think we've beaten the voltage measurement thing to death, and the RF measurement is actually a really interesting topic because I mean that's not you're not going to Adafruit to buy a sensor to do that.
No, you're not. But there's a lot of them out there. There's some very good inexpensive ones, as it turns out. And on the controller side, it's not that difficult to make it work. So you can buy RF sensors from, Bird, of course, Bird Technologies. You can buy it from Telewave. You can buy it from Elecraft, although the Elecraft ones only really work with their watt meter, but you could make it work. And there's a little company that's right here in Silicon Valley called WaveNode, and WaveNode makes a desktop watt meter, and their directional couplers are very easy to work with, and they're very inexpensive. They're about $70, and they're very easy to work with. So the way a directional coupler works is it's a box with two coax connectors, and you put the antenna on one side and the transmitter on the other side. And when you transmit, the coupler's circuit takes the RF energy that's going from the transmitter port to the antenna port, and it creates a DC voltage that represents the amount of RF power going through the circuit. The higher the amount of RF power, the higher the voltage that comes out of the coupler. The cool thing is the way they design the coupler, there's also another sensor part of this that measures the reflected power. So any energy that's going from the antenna back to the transmitter is also turned into a voltage. And so you get two wires plus ground coming out of any of these sensors. You get a voltage that represents the forward wattage and a voltage that represents the reverse or reflected wattage and ground. And then you just have to interpret those voltages into a wattage, and there you go.
So I'm actually looking at this thing right now, and it's a gray box with SO239 connectors on it. And then one side says input, and one side says output. Well, actually, no, this one's for HF. And here's a UHF one. But basically, I mean, yeah, it has whatever the appropriate, like here's one with N connectors, and then it looks like it just has a... oh my gosh, it's like a mini DIN connector on it.
Yeah, it's a mini DIN connector, and you just use 3 of those 6 pins. So here's a little kind of practical tip. So let's say for your own shack, you said, well, I want to monitor the RF power at my antenna.
I would say this actually, like, I'll definitely put this in the show notes because this is super cool.
Yeah. So you could put one of these samplers. You could put it anywhere in the feed line. It turns out that if you want an accurate measurement of the power output of the transmitter, you really should mount the sensor at the transmitter's coax connector, not in an arbitrary location down the coax. Wherever you put the sensor is where you're going to measure power at that point. You know, you might want to put it by the antenna just to see what it is, in which case you could put that little sensor, a little microcontroller, you know, like an Arduino and an XB, and you could be telemetering back to your station what the power is at the antenna.
Or you could have one on both sides, one of the transmitter side, one of the... But
yeah, and you can see what your feed line losses are.
But the thing that's actually stupid cool about this is you could use one of these directional couplers and an Arduino to basically build your own RF power meter.
Exactly right. You can indeed.
This is like Antenna Analyzer 2.0.
So here's another one that's along the same lines. Now we're kind of going off into the weeds a bit, but Elecraft makes a little QRP dummy load. It's cheap. It's like $20 or $25. Mm-hmm. Anyway, it's a connector with a bunch of resistors on a circuit board, and you use it just like a dummy load. But there's a way to put on a capacitor and a diode and rectify the RF and get a voltage. And you could take that voltage and shove it into the ADC of your Arduino or your PIC and write some software to just convert that voltage to a wattage, and now you've got a little watt meter.
Cool.
Pretty slick.
So, well, I got to admit, I mean, so I guess this really is testament to your ability to find off-the-shelf components, because I was hoping you were going to be like, oh, yeah, we totally designed an XYZ, but...
well, so if you break it down, though, like I said, it's a mix and match. So when it came to the RF sensor, the directional coupler, I didn't want to design one. I've never designed one before, and I could probably figure it out. But for $70, I'll buy one. It's just not worth. I'm not interested in designing one. But the controller board, I had to design it because I needed the particular combination of sensors that I wanted. So that, of course, didn't exist off the shelf.
Mm-hmm. So we've talked about voltage measurement. We've talked about RF measurement. I mistakenly mentioned temperature measurement a minute ago. I'm going to guess that you're going to tell us that you're using, and I don't remember the model number, but the little temperature sensors that look like transistor cans.
Yep. Yep, exactly. Yeah, that's a Dallas. Well, it used to be Dallas Semi Maxim now. A DS 18B20, which is a super common, popular digital temperature sensor. We talked about that a couple shows ago.
Yeah, we first brought it up on the idiot switch episode.
Yeah, exactly. And it's just looks like a transistor, but it's a chip inside a little metal can, and you got a 3-wire cable that runs back to the controller, and you plug it in, and the microcontroller just interrogates that temperature sensor periodically, and there you go.
So, what is the? Are there any other major sensors that we've missed?
Well,
I see. We didn't talk. So, I mean, those are sensors. Then you have relays.
Yeah, because we want to actuate stuff, and what we're currently doing at the repeater site is we can power cycle the D-Star repeater, the D-Star computer, the Fusion repeater, the Fusion computer. We can turn lights on and off. We can reboot the IRLP node's computer. So there's sort of a trend here. So we want to be able to remotely reboot any computer at the site. So that's what most of the relays are there for right now.
Now, when you reboot them, is it a drop power and bring, or are you actually sending like a serial command?
No. So what we're doing there, it actually depends. So the IRLP computer, we actually built that out of a mini ITX motherboard and a solid state drive and a 12-volt DC converter. So the whole mini ITX computer, this is before the Raspberry Pis were really able to do IRLP. We built it so it runs off of 12 volts, and we take the 12-volt supply, run it through a relay in the controller we built, and then to the load, to the computer itself. And so in that case, since it's always in the relaxed relay position, we run the power through the normally closed side of the relay. So in the default case, the relay is de-energized and the circuit is complete and powers the computer. So if we want to reboot it, we tell the relay to actuate for a few seconds and then relax, and that will pull power and reapply power.
Okay, now, so it's just a hard drop the machine and bring it back online. You're not.
Yeah, it's nothing elegant at all. On the other two, on the computers on D-Star and Fusion, what we did over there, since those are running, there's a big AC power supply for that. So we took what's called a power pigtail. It looks like a 1 foot long extension cord, which you'd think is pretty useless. In the middle of a 1 foot long extension cord is a plastic box. In the plastic box is a circuit board with a relay and an opto isolator. And so to actuate the AC circuit, we just run a pair of wires from the controller to the little box in the middle. And when you apply 5 volts across 2 pins, then it closes the AC relay and applies AC voltage to the load. And that 5 volts comes off the controller. So one of the things that we did on the controller, on all the dry contact relays, you could either, they're all single pole double throw contacts, and there's 4 of them on the back of the board. In the normal mode, those relays are just dry contacts, put whatever you want through them. We put a header on the circuit board connected to the center common of the relay, and with a jumper, you can apply ground or you can apply 5 volts to the center pin internally. So for that, it was easy to just shove 12 or 5 volts out the pin to the AC pigtail to turn on the computers.
And those are, I'm assuming, the same pigtails we also talked about in the idiot switch episode. So you're not actually having to solder, 120 AC through stuff that you could potentially touch.
That's right. And I think they sell them at Adafruit, don't they?
Yeah, they do. They're like $20 or $24 a piece. And that, and actually, there's even one that, they have 2 kinds. They have one that's, like you said, just the extension cord with 1 connector, and then they have another one that's got 4 plugs in it, which is the one I think made by the company that's not far from where you live.
4 plugs.
Like four plugs that can be.
Oh yes,
not independently switched. It's all or nothing.
Yeah, that's right.
But and because I remember when we talked about that, the 4 plug one was actually cheaper than the 1 plug one.
That's right.
But no, I mean, actually, what's nice about hearing this is that rather than going out and reinventing the wheel for everything. I mean, you did look at what the market has to offer to try to expedite building these, and these are well-known, tested, discrete components. I will share one thing with you about the computer reboot. Mm-hmm. So years ago, for those of you who don't know, Mini ITX it's a motherboard standard, and it's called Mini ITX because they're quite small. But many years ago, a friend of mine and I were building in-car computer infotainment systems, and we would basically mount. You would mount a Mini ITX board like in the trunk, and at the time we didn't have solid state drives, so it was hard drives and shock mount stuff. But there was actually we had it wired to the battery. But for the key on-off position, a lot of cars made available a signal about key position, and we were actually able to take that, and then if the key was turned to the off position, the machine still had power, but you didn't want it to keep running. But we were able to signal through the ATX header this, to simulate a button push to tell the machine to go to, basically to shut down gracefully.
Yeah, that would be a much better way to do this, and we just did the brute force pull the power, but and obviously that's got potential problems.
My mind is going.
Dave?
No, George. My mind is going, George. I can feel it. But okay. And I mean, so at this point, for all intents and purposes, like you said, you have a lot of remote diagnostics. You have the ability to affect a lot of things on or off in the area. I'm assuming, like you mentioned earlier, there's a web dashboard that you get continuous information. I'm also assuming if you wanted to, you could log every time that the receiver is receiving or the transmitter is transmitting, just to say that, well, the transmitter was on for 3 minutes between this and this. Yeah,
actually, we do that. The way we do that, if you're using the version of the gateway that plugs into the repeater controller, we stream the state of the repeater controller to the BeagleBone constantly. So every time a COR, a carrier sense indicate occurs, or a PL decoder occurs, or a transmitter transmits, that state data is sent over the serial bus to the bone, and you could log it there. So and then on the web version of the gateway, anything that's a sensor input, like for example, we have opto-isolated digital inputs. So if you take like the PTT signals of all the transmitters and hook them up to these opto-isolated inputs, we know when the transmitter's on. So all the data that's on the controllers is periodically updated to the gateway, and if you have the connection to the cloud, it just pumps that data up to the cloud. And so you can go get a whole history over time of exactly what the state or the voltage or whatever the wattage was of any sensor over time and see exactly what happened. So that's kind of the diagnostic part. So one of the things that we do with this is, since we're internet connected, we look at fault conditions and we can program into the software a fault. So for instance, if the transmitter is on, but the power output, which should be, let's say, 50 watts, is less than 45 watts, then I want to get a text message that tells me that there's a fault. And that's surprisingly easy to do. So that's sort of been a feature that we wanted to build into this from the beginning. So as a repeater owner, you'll get a phone call or an email like, the repeater's been off since 3 this morning. And you're like, well, I didn't know that. So if you can instrument this stuff, you can also write code to look for alarm conditions and then take some action. The action, by the way, could be to like actuate something. Like if my reflected power is really high, then actuate the coaxial relay to take the power amplifier out of the circuit, or interrupt the push to talk line, or you could do stuff automatically, or you can just send this fault condition to the repeater owner or the user, whatever, as a text message.
So let me, I mean, this is all incredible stuff, but I mean, really the $1 million question, maybe literally, is, again, I've seen the boards you have for your existing repeater controllers today that you can plug the Beagle board into, or the BeagleBone into. Did I understand that you also, for this project, in addition to being able to plug the gateway into the existing repeater controller, do you have standalone gateway boards?
Yeah, there's a standalone gateway. So if you wanted to use this without our repeater controller, or for that matter, even if the thing that you're monitoring is not a radio, it could be something else. Because in addition to the specialty things like the RF monitoring, a lot of this is just generic stuff. Look at a voltage, look at a switch closure. That talks to the gateway, that talks to the internet. It doesn't have to be a radio system that you're instrumenting.
So the $1 million question wasn't that, but are you guys, is this a project that you guys are going to make open source? Is this something that Sierra Radio Systems may productize? Have you gotten that far yet?
No, not, we're kind of in this, in the middle. I mean, we didn't really do this to make a product to start with. We did all this, but this is kind of like the repeater controller. If you kind of rewind to the repeater controller story, we started that project over 10 years ago, back around 2005. And the reason we built a repeater controller, the last thing we were trying to do is sell them. The whole idea was two things. One is in our network, we can't find a repeater controller that met the specs of what we wanted. There used to be one, but the guy went out of business because selling repeater controllers is a fast way to go out of business, it turns out. So we thought, well, we need a repeater controller, and then, it would be a fun thing to work on. So we built one, and the goal was to get it to work at all. And then once we got that to happen, then we said, okay, let's put one on a hill. And we did, and it worked. And then we showed it to the guys in our club, and they were like, well, if that's any good, we should make a bunch. And so we made a bunch, and then, of course, the word gets out, and then people come find us and say, hey, my friend bought one of your repeater controllers. Can I have one? And like, well, okay. So then we figured we needed to make a bunch. And so it turned into a business, but it's not, it's not like we're really making a bunch and selling a bunch. We did it because we needed them. And selling them to people we don't know is kind of a way to cover the costs of all the effort, not the time, that's kind of a giveaway, but the material and the prototyping and all the scrap that you go through. So we do sell the repeater controllers to people that want to buy them, but it's, the motivation was really because it's a really fun thing to do, and our club needed a bunch.
Yeah, and it was problem solving.
It was problem solving. And so we approached this site monitoring thing the same way. It was really just something that was, it's sometimes you get an idea in your head that you just can't shake. And, you wake up in the middle of the night and you think, oh, I got a great idea how to do that thing. And this just became one of those projects where it was a really fun thing to try to figure out and design and to get it to work and all that. And we never really intended to commercialize it. And at this point, we've installed multiple controllers, and they all seem to be working pretty well. And there's a ton of work on the web server side that I didn't do. A couple of friends of mine are experts at that, and they wrote the software on the website, which is way beyond my software development abilities. So I did the hardware and the firmware, but they did the web software. So, so I guess the question is, if someone's listening to this and you want one, would we sell you one? We really don't have them for sale. If you're really, really interested, then I'd be happy to talk to you about it. And maybe at some point in the future, we might make some available and see where it goes.
Well, cool. Just out of curiosity, do you guys have any pictures that you would be willing to share that we could put up in the show notes for this?
Oh, sure. Yeah, we got pictures.
Yeah, because I haven't ever really made that request before, but I mean, seeing some of these things, seeing the installation would definitely be cool. But it's really nice to see that this is with all the microcontroller talk, this is a very practical application, for amateurs in general. And quite frankly, this stuff, we talk about repeater site monitoring, but you could also build station monitoring in your own shack using these same principles.
Oh, totally. And this is the thing that really is a vehicle for learning. So I've learned a ton going through this process. Every time you do a new project, you just learn so many things that you didn't know before. And you also, by the way, come to appreciate other people who know more than you do. Like when we're doing this thing, I mentioned the guys who are working on the software. I got to tell you, it's surprisingly complicated. And like a lot of things, you can make something work. You can make something blink, but to make it work really fast and reliably and with a lot of functionality is not trivial. And things could get kind of complicated.
Well,
but
that's like I always say, there's two ways to do something: the right way and right now. And generally, those are mutually exclusive.
Yeah, exactly.
Well, awesome. Well, George, thank you very much for sharing. Before we go, I actually have a surprise.
What?
I actually have a listener question that I received late yesterday that is a good one. And since I have you, and you're the guy that I would ask such things, I have an intuitive answer for this question, but you could probably provide a little bit more guidance.
Sure.
So we have a listener up in my former state of Washington, which I miss very much. Hello, Pacific Northwest. His name is John, and John asks, John explains that he and his wife are living a fabulous lifestyle, living off the grid in an RV and traveling around, and they have a lot of portable solar equipment. But then, they have batteries on board the RV, and generally everything they do is based on, the onboard batteries, not shore power per se. But one of the more expensive power items that they have in the RV is a refrigerator that kicks on. And in order to provide for all their internet needs, they have what I'm assuming is a little hotspot and something called a MikroTik router. The router has a very flexible power input, they say between 8 volts and 34 volts. But what they're having happen is that they're noticing when the refrigerator is kicking on, which obviously has a very high startup load, due to the inrush current just to get the compressor to start, that there is enough of a total sag on the 12 volt system in the RV that the router will kind of become unstable or will actually reboot. And he was asking, is there anything that they can do to make it survive those brownout periods? And to me, the first thing that came to mind is a capacitor or some type of maybe an up converting power supply. But like you see those on eBay all the time, and I don't know how quickly they respond. So I didn't want to recommend the power supply for fear that you may buy one and it doesn't actually up convert fast enough, or it doesn't respond to change in input voltage fast enough without doing wonky things on the backside. So am I barking up the right tree with a capacitor?
I think you're barking up the right tree with the boost converter.
Really?
I think that's the right way to go, because what you want to do is you want to put out for the capacitor, you need a pretty big capacitor to probably make a difference. It depends on how much of a load that you put across it. So,
this router is 7 watts max,
which is not a lot.
No, it's not. I mean, that's the thing is it's a very low power device.
I would go the boost converter because I've never tested the response time to an input voltage change on the boost converter, and of course it depends on what chip is being used in the boost converter. But I bet they're pretty instantaneous. I don't know why they would have any kind of delay. So that's what I would do. Well,
so the example that I would give is there's a gentleman I follow on YouTube named Julian Leavitt or Levitt. He's a British fellow. And he does a lot of YouTube videos on these ridiculous Chinese contraptions that he'll buy, like Chinese LED fixtures and Chinese boosting or reducing power supply boards and whatnot. And there was one that he used he was very happy with, but I noticed he had it hooked up to a multimeter, and when he first turned it on, he still had input power put to it. And when he first turned it on, the voltage output spiked to like 30 volts. When he had the output voltage set to like 3. And it was one of those things where, okay, maybe the microcontroller hadn't done its thing fast enough. And so that's why I was, doubting will it respond to an instant, basically what's effectively an instantaneous change of voltage. I mean, you may only need to get through the event for 20 milliseconds. So
what's the load voltage he needs?
The device will work between 8 and I think he said 30.
Okay. Well, the other thing would be like what we're designing in the low voltage disconnect, where you can have 2 voltage sources and have the circuit automatically switch over. So he could use our low voltage disconnect circuit when we finish it.
I thought about that as well. And it absolutely would work, but it adds the complexity of having a secondary 12-volt supply that, like a battery or something that needs to, be kept charged independent of the system. But either way, John, you have some options. I actually had done some research last night on the capacitor front. There was a gentleman who had a boat that actually had the exact same problem you are having, except for him, it was another piece of gear. It wasn't a router, but running something on the boat was causing a brownout situation. He was looking for a way to solve it, and the prevailing wisdom there was some combination of a diode and a capacitor. And when we're talking a capacitor, we're talking like a 1 farad capacitor, the kind of stuff that you often will find in like car audio, like big loud stereo installations. But I can at least pass on to you the links that we got. But I thought it would be a good question since we haven't done a Q&A on the show in a while.
No, I think it's an excellent question because there's probably a lot of applications where you run into the same sort of brownout situation. For $10, I would go on eBay and buy one of these boost converters and just try it and see what happens.
Lest you fry your microtik. I mean, at the very least, try it with, a dummy load and a multimeter connected to it.
Yeah, I would be surprised if you power these things on. They really shouldn't have a big overshoot. So if you get a boost converter that has a reputable brand of chip in it, you can look up the chip and see what its settling time is to the target voltage from time zero, and see if there's any overshoot. I mean, for the regulator to be any good in the commercial world, it shouldn't do that. Which is not to say that you can't find one that does. But
remember, for the class of device we're talking about, it is shipped from China to your house in 2 days for $10.
Well, okay. So I'm looking at eBay right now, and I just did a search, and the first one that looked kind of decent uses an LM2577. So that's probably a pretty darn good part. So I would just look at the LM. What was it, 2577 data sheet and see if it looks how stable it is. I bet that's fine. Any part that's from a big reputable company like a TI would be fine. I bet.
Well, awesome.
Well, it's worth a try. Anyway, for $10, and like you said, Jeremy, maybe you do want to do a little test before you fry your microtik. You might put a voltmeter on it, and see what, or a scope would be even better, and see what the time is to settle down.
Yep. And remember that don't do anything that we say. If you try anything, it's on your dime. We bear no responsibility. Don't do a thing that we've said to do. But I mean,
especially if it involves heat
or electricity or danger. We're just. I might actually go back and delete this section. So, George, I think that'll about wrap us up. Again, listeners, we want to hear from you about your projects. Please send an email to workbench@hamradio360.com, giving us a little bit of an overview. No project is too small or too simple, or maybe not even too big or too complex, unless you're building your own satellite. Actually, that would be cool to hear from somebody on.
That'd be awesome.
If any of our listeners are building satellites, please let us know, especially if you're doing it on your workbench. So, George, what do we got coming up next time?
Well, we've got the Baycon episode coming up with a bunch of great presentations, and you're focusing in on these build projects, so I think we got a lot of that. We've got the antenna analyzer, maybe Rev 2 that Barrick's working on. We want to get an update from him once he cracks the code on that. Another thing that's further out is we've got Field Day coming up in June. I realize this is February, but it's never too early to start planning. And so maybe we could do some episodes around gear for Field Day.
Yep, and other topics that we've gotten requests from are how to troubleshoot a transceiver that from the point of knowing that, hey, it's not receiving, what do I do? And also a high-level overview of kind of reinforcing the components in, say, an HF transceiver. Another thing that would be good for us to talk about is as we get ready for Dayton, we always do a pre-Dayton show on the main Ham Radio 360 podcast, but we should definitely do a show focused on the Dayton flea market through the Workbench lens.
That sounds like a great idea. I'd love to do that. Oh, by the way, we are, of course, going to be at Dayton. So if any of you guys are listening that can make it, we'd love to see you there. Last time we had a great turnout. It was really fun that the three of us finally got together, and we had John from his podcast show be there. We had a bunch of guys who stopped by and introduced themselves. Stuart, Mr. National Parks on the Air, was there.
Donald.
We had a great time.
Yep. No, it was amazing. The outreach and the engagement was fantastic. And I mean, I've been looking forward to this all year long, and it is just a short 97 days away as of the time of this recording.
So hopefully we'll see you there.
All right, folks. Thank you once again, as always, for listening. You guys are the best audience in ham radio podcasting, if not podcasting in general. Thank you for your engagement, your words of encouragement, and your feedback. We love when you guys give us feedback. If you want to get that feedback to us, you can email us at workbench@hamradio360.com. Also, if you want to engage with us socially, I am on Twitter at KF7IJZ.
And I'm at KJ6VU.
We also have a Facebook group. Search for Ham Radio 360. That group has actually grown like wildfire over the last several months, especially once we have gotten the antenna analyzer build. And also, if you need help or experimenting with things, there's a forum on hamradio360.com where folks are asking questions, getting help building things, and exchanging ideas on ways to improve. There was actually an effort where folks were trying to use one of the, I think it's the SI 5153, in order to get more bands out of the core design.
Yeah, and that's a nice mod for a future rev of the board.
So thanks everyone for listening. 73.
73 is all.